guys, it's Megan. So today we're going to be going over Unit 7 Chemistry Learning Goal number 1, which talks about how do you compare and contrast ionic bonds and covalent bonds. So we're going to talk about what an ionic bond is. And an ionic bond is when one or more electrons from an atom are transferred to another atom. And we're going to look at the example of lithium fluoride to get a better understanding of this. So lithium has 1 valence electron on the outermost shell, and fluoride has 7 valence electrons. Now, what ends up happening is every atom wants to obey the octet rule. And the octet rule is that 8 is great. They want to have 8 valence electrons on the outermost shell. Very important for ionic bonds and covalent bonds to know that rule. So what ends up happening is that the 1 valence electron from lithium gets transferred over to fluorine because it has 7, which then satisfies it because it becomes 8. And the thing is, when it loses that valence electron, lithium gets a positive charge because electrons are a negative charge. But fluorine gets a negative charge because it's gaining an electron. Like I said before, it has a negative charge, which ends up being lithium fluoride, and that is an ionic bond. Ionic bonds, it's very important to know that they are made up of metals and non-metals. That is the only thing that will create an ionic bond. Versus a covalent bond also wants to obey the octet rule, but in a different way. Covalent bonds are made up of non-metals always. Non-metal and another non-metal bond together, and they share electrons. So the formal definition of a covalent bond is that when the electrons are shared between 2 bonded atoms. So when you take a look at carbon and hydrogen, there's 4 hydrogen atoms and 1 carbon atom. And the red X's stand for the valence electrons from the hydrogen, and the black X's stand for the valence electrons from the carbon, and they're being shared. So as you can see, there's 2, 4, 6, 8. There's 8 valence electrons totaled, but they're sharing them to get that 8 valence electrons. And that's the difference between covalent bonds and ionic bonds. It's also important to note that covalent bonds do not have a charge. Ionic bonds do. So the next thing we're going to address is the second learning goal, which is how do you name and write chemical formulas and molecular names for molecules? And we're also going to define mono through deca. So in order to break down that question, we're going to ask, what is a chemical formula? And a chemical formula tells us the number of atoms of each element in a compound. So what does that even mean? Let's look at an example. So we have glucose right here. Glucose is made up of carbon, hydrogen, and oxygen. And what these numbers mean is that there are how many atoms there are for each element. So right now there's 12 carbon elements present in this compound. There's 22 hydrogen, and then there's 11 oxygen, and that's what makes up glucose. So this is the chemical formula. It's made up of symbols and the number of atoms of each element. But the second question we're going to ask is, what is a molecule? And a molecule is a group of atoms bonded together by sharing valence electrons, or covalently. So this is very similar to a covalent bond. And it's important to know that crystalline structures are not molecules. So metals and ionic bonds are not molecules. But it still wants to obey the octet rule. So let's look at an example. Say if 2 oxygen atoms wanted to bond together. Oxygen has 6 valence electrons in total. Yeah, I did that right. There's 6 valence electrons. But what's going to happen is that they have to satisfy the octet rule. 8 is great. But how is that going to happen? What's going to happen is that 2 from each atom are going to end up adding together to be 4, and they're going to be shared between the 2 oxygen atoms. So these 4 are going to represent for both sides. So if it has 1, 2, 3, 4, because there's 4 left. There's 4 left on each side. 1, 2, 3. 1, 2, 3, 4. This acts as 8 when it's with this atom, and this also acts as 8 with this atom. So these 4 are being shared between the 2 oxygen elements, and they each think that they have 8. So they're stable. And another way to look at this Just through an analogy, and you don't have to agree with my analogy, but I'm pretty proud of it. Say if there was a boy, and he had 2 girlfriends. Each girlfriend, she thinks that he's the only one for her, and she thinks that he's the only one for her. But in reality, he's like the 4 valence electrons. He's being shared between both girls. And in this case, that's okay. That's okay for an example. But disclaimer, boys don't do that, girls don't do that. Do not share your valence electrons. But in covalent bonds, that's okay. To complete learning goal number 2, we're going to talk about how to name molecules. So in order to do that, it's a kind of a simple equation. You have the prefix, the name of the first element, a prefix, the name of the second element with the ending of IDE. And what prefixes are these things. And they tell you how many atoms of that element there are in that compound. And that might not make sense, but we'll go over an example, and that'll further explain it. Now, the rules that we have to follow is because you're working with 2 nonmetals. So which one do you name first? You have to name the one that's more metal-like. So when you take a look at the periodic table, this is just a rough sketch, this represents the further left and the further down you go, the more metal-like the atom or the element is. So let's take a look at an example. Say if you have 1 carbon atom and 2 oxygen atoms, both non-metal. Carbon's probably right about here, and oxygen's probably right about there. Now, in order to follow these rules, there's 1 carbon atom, so you don't have to write the prefix of mono. You don't have to write monocarbon since it's the first written element. In oxygen, you have your prefixes. There's 2 atoms of oxygen in this compound. So you would write di right there, and then you would write your ox or whatever the rest of your thing is, and you change the ending to IDE. So it becomes carbon dioxide based on all of these rules.